You walk into your bathroom one day and find out that you didn't shut off the water valve in the tub. Currently, there are 5 liters of water in the tub, and the rate of water leaking from the faucet is 1 liter per hour. So you determine that the water has been running for 5 hours. Simple math. But you are wrong. It turns out that there was 1 liter of water already in the tub at the start. Oh, didn't think of that. So the answer is 4 hours. Wrong again though. It turns out that there was a water outage 3 hours ago for 2 hours. Then 6 hours? Wait, it turns out that your brother sneaked in an hour ago and dumped 3 liters of water into the tub. Wow. So the correct answer was 3 hours. What happened in this example? When you came up with your first answer, you assumed 3 things without even realizing. First, the tub was originally empty. Second, the rate of water leaking has been the same. Third, there were no sources other than the water faucet that added or removed water from the tub. When scientists determine an age of something old, they often use this same principle, which is the case in what's called the radiometric dating. It sounds daunting, but it uses the same method. It looks at an element that slowly breaks down over time. It measures how fast it's breaking down and how broken down it is currently to determine when the element first started breaking down. This is how scientists claim things like dinosaurs lived tens of millions of years ago, and the Earth was formed 4.5 billion years ago, while the 3 assumptions believed to be true. Actually, however, the assumption of constant breaking down seems to be challenged with more recent discoveries, and it is scientifically possible that there could have been other sources of change. If one of the 3 assumptions is wrong, the claimed dates are also wrong. On top of these 3 assumptions, scientists make one additional assumption before they measure the ages, that the evolutionary timeline or the geologic timescale is pretty accurate to begin with. Wait, what does this mean? Some elements break down completely within minutes, whereas others break down very slowly. You cannot use something that breaks down within minutes to measure something in years. If you want to measure something in years, you need an element that still exists after a few years, but it also needs to show some observable change. If it breaks down too fast or too slow, the measurement is not possible. Now, when scientists perform radiometric dating, they first determine which element to use based on what the geologic timescale says the age should be. For example, if they think it is a dinosaur bone, they pick an element that can measure timescales in millions of years. And then the measurement is compared with the answer they were expecting. If it is way different, they try it again, because they assume they made an error. And the radiometric dating is very sensitive, so if you do the measurement multiple times, you can get multiple different answers. If you ask the people who perform radiometric dating if their assumptions are correct, they would say, yes, because it fits the geologic timescale. If you ask geologists if the timescale is correct, then they would say, yes, the radiometric dating confirmed the timescale. Did you know that dinosaur bones are also frequently measured to be only tens of thousands of years instead of millions? But because this doesn't fit the evolutionary picture, these results are not accepted in the scientific community.